Hello, everyone. Mr. Minnick is my name. Math is my game. And today, joined by an interesting group. It's not the full class size, but they're excited nonetheless. So here we are, Chapter 6, Section 2. The title's Multiplying and Dividing Radical Expressions. We saw a while back that if you have the square root of AB, you could break that apart into the square root of A times the square root of B. So that was true with square roots, and the big idea in this section is that is also true with nth roots. Probably what's more profound than that statement that I just wrote using on the second line down, the nth root of AB is the nth root of A times the nth root of B. What's profound about that, what you need to note is the index here and the index here are, as they say in Spanish, el mismo. What's that mean? El mismo. What does it mean? Positive, not positive. El mismo means not negative. El mismo. These two things have to be el mismo. Equal. The same. Yeah. So we have to have the same index. Okay? The index has to be the same. For whatever reason, I'm having a hard time writing today. Kind of reminds me about what they say about old math teachers, because that's what I am nowadays. You know what they say about old math teachers, don't you? They lose some of their functions. Example number 1. Simplify if possible. Simplify if possible. So we'll look at 3 of these. The first one we'll look at would be the square root of 10 times the square root of 5. The next one we're going to look at would be the third root of 2 multiplied by the fourth root of 2. And the last one we're going to look at would be the third root of 2 multiplied by the square root of 6. There we go. All right. So the first one, anybody think they have an idea what we could do here, what we should do here? Take a 2 and a 5 and from the 10? Not really. This reminds me of the Price is Right game. You ever see the show Price is Right? On the Price is Right show, there's this one game where they have these numbers. So there might be a 6 on this one, and then there's another one, and it might be a 7. And then there's another one where it might be an 8. And it's called Squeeze Play. You ever see the game Squeeze Play? Anyway, I guess what I'm trying to say here is on this, we need to take these two terms and we need to kind of squeeze them together. Using the property that we just saw. Using this property here, but in the opposite direction that's written in. So we need to take the square root of 10 and the square root of 5, and we need to actually multiply, if we can. It's the square root of 50. Nice, good. Shout out to Kat. Square root 50. There is a reason that it is possible to do that in this. Remember what we said about this index and this index? They have to be the same. There's no index there. By default, the index is what? 2. Good. So the index is the same. So we end up with the square root of 50. And I feel like an infomercial host sometimes. We're not done yet. Wait, there's more. We need to break down the square root of 50. Anybody know what that's going to break down into? Well, 5 and 10 is kind of what we started with, so not 5 and 10. We're looking for factors of 50 that are perfect squares. Factors of 50 that are perfect squares, yeah. Nice, 25 and 2. So we could rewrite this as the square root of 25 times 2. And now we could break this thing back apart if we wanted, or we could just go right to the final answer. I think we're ready for it. Anybody got him? Final answer would be 5. And what about 2? Just 2 like that? 2 is going to be rad 2, yeah. So 5 rad 2 would be the final answer there. And then that's it. Tonight, well, the directions are written the way the directions are written for good reason. Number B, simplify if possible. We have the third root of 2 times the fourth root of 2. Any ideas? It would not be 12. Well, let's take a look at this rule that we saw. Got to be the same index. Is our index the same? No. Our index is not el mismo. This and this are not el mismo. So this is not possible. Not possible. Somebody might be thinking to themselves, the radicand is the same, 2 and 2. Well, we didn't say anything about the radicand. The index has to be the same, and the indexes or the indices are not the same. Number C, what do we think about that one? Not possible. Again, why not? The indexes are different. Nice, good. Not possible because the index... is it okay to abbreviate or to write index plural as indices? Is that the right plural form? Okay. The indices are, instead of saying are different, I'm just going to write differ. The indices differ. Sound like I'm a Loyola professor, graduate professor. Not possible. For the indices differ. I can't do any kind of accent like that. I have a couple good accents though I could do. A couple good impressions. One of whom? Huh? An impression of who? I can't impersonate Arnold. Arnold, get to the chopper. I can't do that. I can't do an impression of Arnold. Sorry. Let's try this one. Let's try this. Let's go with the third root. Third root of 54 x cubed y to the 6. So the directions here are going to be to simplify this expression. Simplify. I don't know if anybody knows who Don Knotts is, but I had a high school classmate whose dad sounded just like Don Knotts. Don Knotts was the sheriff from the Andy Griffith Show, and he had a really, really high-pitched voice. Hey, Andy, why don't you come over here and bring me some of those bagels? That's how he talked. It was crazy. It was crazy. Anyway, example 2 is 54 here. It'd be nice if we could break that down, but we can't. On yesterday, I was talking about it being 62 and partly cloudy in Newton Falls. It's handy if we know what some perfect cubes are, because we're trying to take a cube root. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. So in that list of perfect cubes, it might be handy if we can somehow see some relative, some way to take 54 and break it up. Anybody see it? Which one of these is 54 a multiple of? Is 54 a multiple of any of these? Wouldn't 54 be 27 times 2? Okay. So what we can do with this then is we're going to rewrite this as the third root of, we're going to rewrite the 54. That's 27 times 2. 27 times 2. X to the cubed, or x cubed is already a perfect cube, so I kind of like that the way it is. X cubed is already a perfect cube, so that one's good. And then y to the sixth is also a perfect cube. So that's kind of nice. So because of this third root of 27, does anybody know what is going to come out from underneath the radical? A what? It happens to be my favorite number. We're going to get a 3 out. The third root of 27 is 3. What about the third root of x cubed? What's that going to be? Third root of x cubed, isn't that going to be x? And then what about the third root of y to the sixth? Third root of y to the sixth would be y to the sixth divided by 3. Y to the second power, good. So I mentioned about being 62 and sunny in Newton Falls, or 62 and partly cloudy. There's 3 people outside playing basketball, because you know they like their basketball in Newton Falls. But guess what? There's somebody inside watching the Jerry Springer show. So what's going to be inside watching the Springer show? What's going to be inside watching the Springer show? Anybody? We got the 27 taken care of. We got the x cubed taken care of. We got the y to the 6 taken care of. So what's left? There's a 2. There's a 2 underneath the radical. And that's how we do in example 2. Any questions so far? So there's a question, what are we doing? We are in the midst of talking about multiplying and dividing radical expressions. So far we've seen a couple of rules. We saw a couple of examples. In example 1, we said if the indices are different, you can't simplify these by multiplying. Example 2, we just wrapped up, and we saw one of those on yesterday. Okay. In case anybody watching this back at home is curious, some of the class was gone, and they're making their way back right about now. I think it would be prudent at this juncture to give a shout out. I'd like to give a shout out to the people in Newton Falls for being so good at playing basketball when it's 70 and sunny out. They're good all the time at playing basketball, actually. All right. Well, we got a long way to get with this. Example 3. Bless you. Simplify. Example 3, we're going to try to simplify something like this. The fourth root of 15x squared y to the 7th multiplied by it's going to be a long day today. Anybody know why? Is it a full moon? Let me make this multiplied by the fourth root of 5x. And then we go ahead and multiply that by one more thing. Dang it. Dang it. I might have to multiply this by 2 more things. Sorry, this is taking a little bit longer than I had planned on. I'm going to multiply this by the fourth root of 3y squared. I'm going to go one more time with this. If you get this example, you'll get just about any of these. Um, um, one more time. I don't understand why that wouldn't work though. Let's make. Oh, oh gosh. Anybody else having a bad day so far? A bad day so far? Just a bad day. I'm having a bad day so far. I'm sorry. Hmm. Well, I'm gonna scrap this whole thing. I'm sorry. I'm sorry. I'll hold the microphone to my neck. You could probably hear it. I just necked myself. Okay. All right. Let's try this again. Fourth root 27 x cubed y multiplied by the fourth root of 9 x squared y to the 8th. There we go. That'll work. I'm so sorry about the problem there. So a problem like this kind of reminds me of eating KFC chicken. You know, you could go to KFC and you could get chicken on the bone, and you got to pull that chicken apart. And then you got all kind of mess, and then you got some skin on the one spot, and you got some other stuff. And then when you're all said and done and you go to leave, you got all your trash. And some people leave their trash on the table, which I think is rude. I take all my trash and I put it together in a cup, in my cup, and I make one little package of trash when I leave. I'm proud of myself when I do that. My wife thinks I'm a nerd, but and I probably am. But anyway, what I'm getting at is sometimes you can pull things apart. So this number 4, you might be able to pull some of this apart, or maybe this one you could break some of this stuff apart. But sometimes it's better to take the whole thing. And I know this probably isn't making any sense at all right now. And put these two things together, and that's probably what we're going to do to start. So what I'm getting at is we're going to take the fourth root of 27 times 9. 27 times 9, in case you don't know, I have a calculator handy. 27 times 9 is 243. That's 243. And then x cubed times x squared. X cubed times x squared. How many x's is that going to be? X to the 5th. Good. X to the 5th. And then y times y to the 8th is going to be y to the 9th. But maybe I don't want to write it as y to the 9th. Maybe I want to leave that y to the 8th times y. Does anybody know why? Because even odd roll, and because my index is 4, I'm going to be dividing all these exponents by 4, right? And so this whole term is going to be a nice perfect fourth. You with me so far? All right. So if I break the x down, maybe I should have broken the x up a different way. How could I rewrite this x to the 5th so that I have a perfect fourth in that? X to the 4th times x. Good. So then I'm still going to have that y to the 8th times y. And there's one more thing that needs to be split up, 243. And I'm going to need to try to split 243 up into a perfect fourth. So it might be handy if I have my handy list of perfect fourths nearby. 1, 16, 81, 256, 625. So is 243 a multiple of any one of those? Is 243 a multiple of any one of those? Is it like 81 times 3 or something? It is. It is 81 times 3. It is 81. It is 81 times 3. Okay. So it's 64. It's 62 and sunny in Newton Falls. Here we go. It's a fourth root. So we have some people who are going to go out inside and play basketball. some people who are going to stay inside and watch the Springer show. Because of the fourth root of 81, who's going out and playing basketball? A 3. So because of the fourth root of 81, a 3 is going to go out and play basketball. Because of the fourth root of x to the fourth, who else is going out and playing basketball? X. Because of the y to the 8th, who else is going out and playing basketball? Y squared. So we still have this fourth root left over, and there's some people watching Springer. Who's watching Springer? This 3 here is watching Springer. This X here is watching Springer, and this Y here is watching Springer. Now, you know I love Chinese food. I was just going to say something about that. We ordered Chinese food, and you know what they say, and yeah, we need an absolute value around what? The X? Good. There it is. Nice. Question. There's some confusion how we got the 3xy squared, about how we had the stuff that comes out from under the fourth root. Okay. So what we need to look at is taking fourth roots, because I think this is a concept that's new to some people. We all know how to take the square root of 16, and that's 4, right? If we look at our list of perfect fourths, in our list of perfect fourths, we have 16 there. If we take the fourth root, of 16, that says what number multiplied by itself 4 times is 16, and that would be what? 2. Okay. So the only thing that's going on any different in this expression here is we've just got a lot of things that we're looking at all at once. So if we were to zoom in on this fourth root of 81, that gives us this 3 over here. If we look at the fourth root of this x to the fourth, that gives us this x out here. If we look at the fourth root of this y to the 8th, that gives us this y squared. So what we've done then is we've essentially wiped out that 81, that x to the fourth, and that y to the 8th, and it just leaves the other things under the radical. I don't know if that answers that or clears that up. Are there any other comments, questions, concerns, short debates? Okay. Well, you know what somebody always likes to ask? When are we going to use this in life? When you're running the Iditarod and that sled dog needs to be mended. Yep. Also, is this going to get any more difficult? Well, let's look at the title. What did the title say? Multiplying and... Oh, no! So, we saw that the square root of a over b is the square root of a over the square root of b. Similarly, the nth root of a over b can be thought of as the nth root of a divided by the nth root of b. All right? Keep in mind that the index, the root that we're taking, fourth root, square root, cube root, the index has to be the same in order for this property to work. Also, if we're talking about square roots, if we're talking about fourth roots, I would be remiss to not mention the fact that we cannot have a negative radicand. Remember, you can't take the square root of a negative, and you can't take the fourth root of a negative, so we got to be careful there. All right. So we're looking at example 4. Going to try it. Example 4, simplify. Simplify. The third root of 625 x to the 19th, y to the 14th, divided by the third root of 5x y to the 9th. There we go. So what that last property says is we're allowed to, since the indexes, since we're taking a cube root and a cube root, since these are the same, we're allowed to kind of play a squeeze play with these across the fraction bar. In other words, we're allowed to take the third root of one big fraction, 625 over 5. What's 625 divided by 5? Anybody know? Isn't that 125? Okay, so that's going to be 125. And we're going to have x to the 19th over x. Well, what's that going to simplify to be? X to the 18th. So that's going to be x to the 18th. And then we're also going to have y to the 14th divided by y to the 9th. So what's that going to be? Y to the 5th. That's going to be y to the 5th. What do we think so far? Make sense? Okay. Well, I spy 2 unicorns. You know what a unicorn is, right? Something that doesn't exist. Like when things are perfect. Like when we have a perfect cube. And when we have another perfect cube. Oh my gosh, this isn't going to be that bad at all, is it? Well, hold on a minute. We know what the third root of 125 is. And the third root of x to the 18th is going to be nice. But I need to reproportion that y to the 5th. Can anybody read my mind? Y to the 3rd times y squared? Yeah. Some people can't read my mind. Those of you with that special gene, you can read my mind. They told me not to talk about it in the last debriefing, but I'm sorry, I shouldn't have said that. I said too much. In case I don't see you tomorrow, it's been real. And it's been fun. I don't know if it's been real fun. I'll let you be the judge. So, what's the third root of 125 going to be then? 5, third root x to the 18th? X to the 18 divided by 3, or x to the 6. And because of the y, so this is done. Because of the third root of y cubed, what else pops out? A y is outside playing basketball. So there's a lot of people outside playing basketball in Newton Falls today. What's watching Springer? Y squared's watching Springer. The one and only. Any questions about example numero 4? We're almost done with this, if you can believe that. Probably 2. 2 more examples. So, 3 divided by the square root of 2. I don't know if you remember seeing something like that, but mathematicians can't stand certain things. This is one of them. Having a radical in the bottom in the denominator is horrible. Mathematicians, they cry when they see this. Why? Because it's kind of like nails on a chalkboard to mathematicians. I'm not crying. Well, I'm not a mathematician. I'm just a nerd. I'm just an old math teacher. The math overlord, that's right. I haven't heard that in a long time. So the trick is we got to multiply this by 1 to solve this problem. We would like the denominator to eventually turn into a unicorn so that we can get the radical to go away. So does anybody remember what we multiply by here? Not the reciprocal. We need the denominator to end up being some kind of square root of a perfect square so that we end up with no radical in the denominator when this is all said and done. Just a number. So we need to turn 2 into a perfect square. Kind of like the magical tractor. Times it by 4. Well, we don't even need to times it by 2. So, but we're working with something under a radical. So what we're going to do is multiply by radical 2 over radical 2. So what that's going to end up happening what's going to happen with that is this radical 2 and this radical 2 under the radical is going to become radical 4. And what is the square root of 4? It's just 2. And we got to remember what happens in the numerator. In the numerator, we still got this 3 times the square root of 2. And we still end up with that 3 times the square root of 3 times the square root of 2. Okay. So that's the answer to that one. And now, you should have seen that in geometry. And earlier in the year in Algebra 2, when we studied the unit circle, I briefly mentioned that. So this is the toughest part of this chapter. You ready for it? Last example of the day. Simplify. Simplify the third root of 24x to the 4th divided by the third root. Oh no, I'm sorry. My bad. Let's try that again. Third root of 24, was it x to the 4th? X to the 4th over 5 y z squared. So if we were to break that apart, we're going to have the third root of 24x to the 4th over the third root of 5y z squared. Okay? The problem is this thing down here, this 5, that's not a unicorn, and I want it to be a unicorn. The y is not a unicorn, and I want it to be a unicorn. The z squareds. So we're almost done here. We got to turn 5 into a unicorn, y into a unicorn, and z squared into a unicorn. What I mean by that is we want each one of those to be a perfect cube. So let's think of our perfect cube list again. Perfect cube, 1, 8, 27, 64, 125. I need to take this 5 and I need to multiply it by something that's going to make it a perfect cube. If I multiply 5 by 5, that gets me 25, which is a perfect square, but I'm trying to get a perfect. If I multiply it by 25, yeah. If I multiply that by 25, that's going to make 125. That's going to make a 125 under this third root, which will be a unicorn. Okay. What am I going to have to do with the y, though? Y squared, okay, so I'm going to do a y squared here, and then just a z, and then just a z. So this whole thing here, this whole thing is my 1 that I'm multiplying by. So I also have to multiply the numerator by this third root of 25 y squared z. Oh, man. So in the denominator, I'm going to get the third root of 125 y cubed z cubed. And in the numerator, wow. 25 times 24, ain't nobody got time for that. Nobody. I think it's 600. $25 times 25, 625. Yeah, it's 600. So I'm going to get a third root of 600, x to the 4th, y squared z. Okay, still not done. I told you this one's bad. This is the worst of them. In the denominator is going to be nice. The denominator, what's the third root of 125? 5, and the third root of y cubed, y, and the third root of z cubed is just z. So up top, 600. Oh, man. Um, 600, doesn't that have a factor of 8 in it? One thing that we might have noticed earlier on is that 24 has an 8 in it, and 8's a perfect cube, isn't it? So that 600 could be rewritten as the third root of 8 times 75. X to the fourth could be rewritten as what? X cubed times x, and then the y squared, and the z is going to be what it is. So our final answer here, it's a mess. Now this is a nasty problem. Third root of 8, what is that? 2. Third root of x cubed, x. Y squared, nothing comes out up top from the y's, nothing comes out up top from the z's. So watching Springer, we're going to have what? 75 x y squared z. And in the denominator, we have 5yz. That's the worst of them. Those ones are like on a 1 to 10 scale, about a 9. They do get a little bit more difficult than that, but those are pretty nasty. 1 to 10 scales are relative. And I'm not talking about Wyndham or West Virginia. So that's it. Any shout outs? The future Mr. Minnick, thank you. Anybody else? Travis? Anybody else? Mackenzie Click? Anybody else? Who? Maddie Caldro? It's been real. It's been fun. See you next time.
Good.